Welcome to Sunny's Mindset Lab. Today, we're exploring a powerful idea that directly impacts how we learn, change, and grow: neuroplasticity, with Dr. Lara Boyd, based on her research-driven TEDx Talk. Thank you for having me. Neuroplasticity shows us that the brain is constantly changing, and that we each have the power to shape our brain through our actions and experiences. For a long time, the medical consensus was that after childhood, the brain was essentially fixed. It was thought that once we reached adulthood, our neural architecture was permanent. Dr. Boyd, why was that the prevailing theory? We simply lacked the technology to see the brain's activity in real time. We used to believe that when a person was at rest, their brain was silent. But advances in MRI, specifically fMRI, prove that even when you are thinking of nothing, your brain remains highly active. fMRI, or functional magnetic resonance imaging, is a technology that measures brain activity by detecting changes in blood flow throughout the neural tissue. The most transformative finding from this research is that every time you learn a new fact or skill, you are physically changing your brain. We call this neuroplasticity. This research reveals that learning is the active physical remodeling of human biology. We are essentially restructuring our own anatomy through the acquisition of knowledge. What does that remodeling actually look like? If we could look under a microscope while someone is learning, what physical processes would we see? It happens in three ways. The first is chemical. The brain functions by transferring chemical signals between cells called neurons. To support learning, the brain rapidly increases the concentration of these chemical signals, supporting short-term memory. The second way is structural. During learning, the brain alters the physical connections between neurons, forming the basis for long-term memory. We see evidence of this in people who read Braille. They possess larger hand sensory areas in their brains than those who do not. The physical structure of their brain has adapted to their behavior. We also see it in London taxi drivers. To get their license, they must memorize a complex map of the city. Research shows they have larger brain regions devoted to spatial and mapping memories because of that intensive practice. The third way is functional. As you use a brain region, it becomes more excitable and easier to use again. With learning, entire networks of brain activities shift how and when they are activated. So learning is a coordinated cascade. It begins with chemical signaling, moves into physical structural changes, and culminates in a neural shift, altering how our network functions. That explains the piano paradox. Many of us have practiced an instrument, felt ourselves getting better in a single session, but then realized the next day that all those improvements were gone. Why is that progress so fleeting? In the short term, your brain was able to increase the chemical signaling between your neurons, but those changes did not trigger the structural changes necessary to support long-term memory. Short-term performance gains do not always reflect actual learning. Permanent memories require time and physical reorganization of the brain circuitry. My research shows that struggle is actually the catalyst for this change. Increased difficulty during practice leads to more learning and greater structural change in the brain.
Easy, frictionless practice yields only temporary chemical spikes. To force the brain into a state of physical reorganization, we have to engage with the friction of difficulty. MRI technology has allowed us to move beyond theories. We can now observe exactly how different behaviors drive neuroplasticity, particularly in patients recovering from brain damage. Does this mean that if everyone just follows the same formula, like the popular 10,000-hour rule, everyone will achieve the same results? I study this specifically in stroke recovery. Stroke is a leading cause of long-term disability, and we have found that helping the brain recover is incredibly difficult because every brain reacts differently to practice. This chart shows the recovery patterns of patients given identical doses of practice. There is no single trend line. Practice hours don't predict recovery because variability is extreme. This is driven by biomarkers, unique characteristics of an individual's brain structure and function, specific patterns that influence how a brain reorganizes. By matching specific therapies to these biomarkers, we can move toward personalized medicine. This allows us to give each individual the specific intervention their unique brain requires. A standardized formula fails because it ignores biological reality. Identical behaviors produce divergent results based on the unique structure of the learner's brain.
Dr. Boyd, if clinical recovery requires personalized medicine, does that mean our education system should move toward personalized learning? Exactly. This split screen shows why traditional settings fail so many. Each of our brains is unique, which is why some children thrive in traditional classrooms while others do not, and why some of us learn languages easily while others excel at sports. However, we must remember that neuroplasticity is a double-edged sword. It does not only work in our favor. Neuroplasticity is the same mechanism that reinforces drug addiction, cements chronic pain, and allows us to forget skills we once knew. The brain structurally reinforces the patterns we repeat. Your brain is shaped by everything you do, but it is also shaped by everything you choose not to do. Neuroplasticity is a constant, bidirectional process. It optimizes our biology for whatever habits we repeat, whether those habits are healthy or destructive. What is the most important takeaway for someone who wants to start using this science today? Study how you learn best. Understand that the strategies that work for music might not work for athletics. Your brain requires a personalized approach, even within your own life. Repeat healthy behaviors and break the habits that are not. Learning is the physical work required by your brain. You have to do that work to build the brain you want. Dr. Boyd, thank you for sharing these insights. This conversation gives our listeners a clear look at how their brains can change and grow. It was my pleasure. I hope this encourages everyone to take an active role in shaping their own neural landscape. This has been Sunny's Mindset Lab. Thank you for joining us. See you in the next episode. Biological destiny is not a static condition. We possess the capacity to physically sculpt our own neuroanatomy through deliberate practice and behavior.